The night is quiet. The stars hang still above. And then, everything changes. Without warning, the Earth's rotation halts. No slowing. No warning signs. One moment, our world spins at over 1,600 kilometers per hour at the equator. Next, it stops. The ground lurches. Oceans surge. A wall of air races across continents. Civilization faces a force no structure was built to endure. This isn't a scene from a disaster movie. This is a question of physics and survival. What would happen if the Earth stopped spinning overnight? Defining the scenario. To understand the scale of this event, we first need to grasp what's happening right now. The Earth spins once every 24 hours. At the equator, that's a speed of roughly 1,670 kilometers per hour. Closer to the poles, the speed is slower, but the entire planet, land, water, and air, is in constant motion. If the Earth suddenly stopped, everything on its surface would keep moving. Buildings, oceans, people, the entire atmosphere. It's like being in a speeding car that suddenly hits a wall, except the car is an entire planet. This isn't just a dramatic image. It's a literal application of Newton's first law: objects in motion stay in motion. So, what happens when 1,670 kilometers per hour of momentum suddenly has nowhere to go? The consequences unfold step by step, and each is more catastrophic than the last. The element of change, inertia on a planetary scale. The key factor here is inertia, the tendency of objects to resist changes to their state of motion. Right now, everything on Earth moves smoothly with the planet. But if the planet stops spinning abruptly, the land beneath your feet halts, while you, and everything else, keeps moving eastward at incredible speed. For anything not anchored deep into the bedrock, the result would be apocalyptic. Skyscrapers would crumble as the upper floors sheared off from their foundations. Trees, vehicles, animals, entire cities would be flung into the air as if a hurricane and earthquake struck simultaneously. But this is only the beginning. Step by step, what would happen? Step 1. The atmosphere keeps moving. Even though the ground has stopped, the atmosphere hasn't. Earth's atmosphere is a massive fluid shell moving along with the planet's rotation. If the surface suddenly stops, that air keeps racing eastward at more than 1,600 kilometers per hour. This would generate winds stronger than any hurricane in history, sustained, planet-wide shock winds. Entire forests would flatten. Buildings would disintegrate. Dust, sand, and debris would fill the air, turning the winds into abrasive walls of destruction. These winds wouldn't last for just minutes. It would take days or even weeks for the atmosphere to stabilize relative to the now motionless ground. Step 2. The oceans surge. Next, the oceans. Just like the air, Earth's water is also in motion. When the crust stops suddenly, the oceans keep going, piling up against coastlines, rushing eastward in megatsunamis hundreds of meters high. Every coastline facing east would be obliterated first. Cities like Tokyo, New York, and Rio de Janeiro would be wiped off the map within hours. As water sloshes violently, inland areas would also be inundated as the oceans resettle. Entire continents would face unprecedented flooding. Step 3. The day and night reversal. Our 24-hour day exists because of Earth's rotation. Without it, a single day, sunrise to sunrise, would last an entire year. Half the planet would face continuous sunlight for 6 months. The other half would be plunged into endless night. The sun would appear to freeze in the sky. On the day side, temperatures would soar, boiling rivers and creating uninhabitable deserts. On the night side, they'd plummet far below freezing, locking the land in ice. The balance of life, built on daily cycles, would collapse. Step 4. Gravity and shape shift. Earth isn't a perfect sphere. It bulges at the equator because of its rotation. If the spinning stopped, gravity would pull that bulge back toward the poles. The oceans would begin migrating toward the poles, flooding higher latitudes while exposing equatorial regions. New land masses would rise around the equator, while northern and southern areas would drown under newly redistributed seas. Major cities near the poles could end up underwater. The equatorial belt could become vast, dry plains. Step 5. Magnetic field breakdown. Earth's rotation helps power its magnetic field through the motion of molten iron in its core, the geodynamo. If the planet stopped spinning, The magnetic field could weaken or even collapse. Without this shield, solar radiation would bombard the surface. Satellites would fry. Power grids would fail. Life would be exposed to intense cosmic rays, increasing cancer rates and damaging ecosystems. Historical and scientific context. This might sound like pure science fiction, but planetary rotation and changes to it are a real part of cosmic history. Billions of years ago, Earth spun much faster, completing a day in just a few hours. Over time, tidal interactions with the moon have gradually slowed the rotation. Even today, days lengthen by a fraction of a second each century. And we've seen what happens when celestial bodies have little or no rotation. Mercury spins so slowly that its day lasts almost 2 Earth months. Its surface experiences extreme temperature swings, scorching heat on the sunlit side and freezing cold on the dark side. Venus rotates in the opposite direction, incredibly slowly. Its day is longer than its year. As a result, its atmosphere is in constant chaotic motion, creating hurricane-like winds that circle the planet endlessly. These worlds are real reminders. Rotation defines everything about a planet's environment. Long-term consequences. Assuming Earth somehow survived the initial catastrophic stop, the winds, the waves, the destruction, what would the new world look like? Human civilization would face a fundamentally altered planet. New continents. Equatorial regions would emerge as massive new land masses, while the poles would flood. Global maps would have to be redrawn. Extreme climates. Half a year of daylight and half a year of darkness would create brutal climate zones. Only narrow twilight regions between day and night might remain habitable. Global collapse. Modern agriculture, power grids, and trade networks, all built around 24-hour cycles, would fail. Mass migrations toward temperate twilight bands would follow. Biosphere upheaval. Plants and animals evolved for daily rhythms would face extinction. Some might adapt, but most ecosystems would collapse. In essence, Earth would become 2 planets, a scorched one and a frozen one, with a thin ribbon of survival between them. The bigger picture. The Earth's spin is something we never think about. It's invisible, silent, constant, yet it shapes everything. The winds, the seas, the climate, even the rhythm of life itself. A sudden stop would turn our stable world into a place of chaos, destruction, and permanent transformation. But this scenario also reminds us of something profound. The forces that keep our planet stable are fragile. We live in a cosmic balance, spinning through space, protected by the quiet hum of rotation. So, what if the Earth stopped spinning overnight? The world as we know it would end in wind, water, and silence. Civilization would vanish. Landscapes would shift. A new, alien planet would be born from our own. And it raises another question. If rotation is so essential to life, what would happen if the moon, our silent partner in this dance, suddenly disappeared? Next time, what if the moon vanished from the sky?